Thanks, Teresa. It's so nice to see everyone here this afternoon. My name is Raelani, as Teresa said, and I see this info coming in the chat, but I do think that we are a small enough group that it would be great to take a couple of minutes at the beginning of this session and have people introduce themselves if they are so inclined. So I'm curious if folks could say their name, where they're joining from, and like what you farm, if you are farming, or if not, like what's your interest in cover crops, and then end with what is your favorite cover crop. I would love to know what you like to grow. All right, well, thank you for all of those introductions. For the record, I think my favorite cover crop of the moment, and it does change, is maybe a subterranean white clover. I feel pretty interested in kind of underseeding and how you can layer cover crops with cash crops in both space and time, and those kind of really low growing white clovers are pretty neat, and it's a nitrogen fixer, and who doesn't love that? So to build on kind of what the information Teresa was giving at the beginning around the land acknowledgement and the acknowledgements that all of you made for the individual places where you are calling in from, I want to, in my turn, respectfully acknowledge that I live and work on the traditional, ancestral, and unceded territory of the Comox First Nation, which is on Vancouver Island in the Comox Valley. And I work primarily in soils, but in agricultural systems generally. And a part of one way that I relate the work that I do to kind of this bigger conversation around reconciliation is actively working to kind of what in the wording of the Truth and Reconciliation Commission's call to actions, repudiate concepts used to justify European sovereignty over Indigenous lands and peoples, such as the doctrine of discovery and terra nullius. So when we talk about soil management, like we're going to talk about today, in the spirit of stewardship and of soil health, I think it is important to recognize that these lands that we work on as farmers or otherwise have been managed since time immemorial by Indigenous peoples. So to give you an idea of kind of what this session is going to go into, we're going to talk a little bit just generally about kind of cover crops, make sure we're all on the same page about what they are and how we can use them. And then I want to go over some tools that are available to help you choose the cover crops that best suit your needs or desires on your farm. And then Teresa sent me a few questions that y'all had sent in before the session, and I pulled up some resources to answer a few of those. One about, how do we figure out how much nitrogen is coming out of these cover crops we plant, and another question about waterfowl grazing. And then I think we'll have a healthy amount of time for questions or discussion at the end if things come up. I would love to encourage you along the way to put any questions you have in the chat, and I will try and keep my eye on those, and Teresa would love your help in doing that. I do see that there is already one in there. What is underseeding? And underseeding is when you have a crop already growing. If you can imagine maybe like a broccoli plant or something, and you would seed a cover crop underneath it while it's still growing. So it's a way of like doubling up in time. It's pretty common in corn production systems also. So great question. All right, so as I am coming kind of from a soils perspective, and a lot of the time when we're talking about management of our farms or like building soil, we're really talking about how as farmers we can promote soil health. And we have these 5 general principles of soil health that I think are really useful framing to start. And they are to cover the soil is the first principle. So, or armor the soil, as it's sometimes said, and that can come in a variety of different fashions, biological or otherwise. The second principle of soil health is to minimize soil disturbance. And we can think about that disturbance in terms of frequency, how often we move or rotate or disrupt the soil, and to what depth we do that. So minimizing both the frequency and depth of disturbance. The third is diversity. So that is referring to both above ground and below ground diversity. So a diversity in plant species that we're managing, which is always reflected back to us in the diversity of soil biota that are present in our fields. So different plants create different exudates or animal foods, soil and microbial foods. And so having a diversity of plants attracts and is able to feed and sustain a diverse array of soil biota. The fourth principle is continuous living roots. So thinking about how much of the year we can keep living roots in the ground, in part to support those biological communities, and then for other kind of more physical and chemical reasons. So the structure of roots physically helps to hold soil in place. And then number 5, how do we integrate animals? And that really is coming from a nutrient management and circulation perspective. So with this framework, we can see that cover cropping actually fits into a lot of these different principles. It is a way to keep the soil covered. It's a way to introduce diversity. There might be plant or crop species that we don't normally grow in our cash crops that we could introduce in our cover crops. It's a way to keep living roots in the ground, especially when we're talking about overwinter cover cropping or between succession cover cropping where the ground might otherwise be bare. And then there's potential to integrate animals in cover cropping systems when we think about grazing management also. So the disturbance piece can be kind of tricky with cover crops. We'll talk about some kind of the benefits and trade-offs here. Often cover cropping management is done with tillage. So that's definitely an introduction of the soil disturbance. Doesn't have to be that way always, but it's definitely one consideration. So I think with that piece of it, the kind of biggest questions that I hear about cover cropping from people are, what do I grow and when should I plant it? So those are kind of like the beginning questions. And then as you get more experience growing cover crops, the questions become more fine-tuned to kind of the challenges of your particular area, like what's going to grow well in this area that tends to flood or have standing water in the winter. I have a lot of wireworms. How can I deal with that? These types of questions. But in general, the type of cover crop that you want to grow really depends on when you want to grow it and what your goals are. So this is kind of the first definition that you need to define for your farm or for a particular cover cropping project to help you choose the species. Because cover crops are just one tool in your box for either nutrient management, soil cover management, diversity management, but they're not the only tool. And there will be times when they make sense and times when the constraints or limitations or disturbance or just a general not fitting in with the rest of your farm system will make them not the right choice. So it's really good to define the time windows and the goals to get you started. So when we talk about timing, generally speaking, there's kind of two general categories. We can have a winter cover or a summer cover. And in the realm of winter cover, there's kind of two strategies. One would be a cover crop that's planted sometime in the fall that will establish itself and then stay alive over the winter and into the spring, at which time you would terminate it mechanically or otherwise to plant your cash crop. There's also winter kill cover crops, so the timing of planting would be similar, but this type of species you would plant and then you would expect that it would die, but you're hoping that there's enough biomass built up by that cover crop in the fall, maybe even late summer, that by the time it dies in cold temperatures, any biomass is now like laid down on the soil and is providing some protection as a form of mulch. So that's overwintering cover crops and winter kill cover crops. And then summer or growing season cover. These are cover crops you would grow, in your growing season. They might be faster turnover crops, summer annuals, things that are going to grow quickly, but wouldn't withstand any sort of cold temperature. Now, the goals themselves can be numerous. So I heard already people kind of articulating some of those ideas in their descriptions of their farms or their experience with cover cropping. So sometimes you're looking at erosion prevention. We think about that a lot, either erosion prevention or soil structure maintenance here in kind of this area of British Columbia, because we're getting so much rain in the fall and the winter. And at this time that we don't have crops growing, we don't have roots in the ground holding that soil in place. The soil is really vulnerable to kind of dissolving or to erode away. And so we might be thinking about using cover crops as a way to prevent that erosion. But you can also, and I heard some heavy clay soils, your goal might be to break up some sort of compaction or to build that soil structure and increase water infiltration. Sometimes people are interested in building up soil organic matter. So building up more of that biomass, adding more carbon to the ground. And then there's the big question of nitrogen. So how do we use cover crops as in our suite of nitrogen management tools, which especially for those of you who are either certified organic or managing your farms in line with organic practices, this can be one of the hardest balances to strike, because there's such a limitation on the types of nitrogen you can apply to your fields, and the timing and total release of the nitrogen can be just really hard to predict. So these are some examples of goals. There are many more than this. And when you're thinking about a particular cover cropping project, or, and by that I mean like you might be thinking, okay, I have this field that I want to cover over the winter. It's kind of a defined space and a defined goal. Like that would be one project. When you think about that, I would encourage you not to identify more than 3 goals, because it's, cover crops have different strengths and weaknesses, and you'll be able to select kind of a good mix of cover crops or single species cover crop for goals if those goals are a little bit more defined. So kind of picking anything from 1 to 3 goals to really focus on. And I see that we have a thistle suppression goal in the chat. Yeah, that's a really hard one. All right, so when we've identified the timing that we want the cover crops in the ground and what our goals are, then we have to think about what are the constraints of this particular project. So a big one will be timing. So when is the ground even available for cover cropping? When are my cash crops going to be in the ground and out of the ground? And then also weather. So soil moisture is going to be a big one, like when the soil might be too wet to be pulling seeding cover crop, getting it established. So thinking about when are realistic time windows for establishment and termination of a cover crop. And this is something that seems, more and more difficult, is my impression, just as kind of year to year weather becomes harder to predict. In the last couple of years, if you were someone trying to seed a cover crop or keep a cover crop alive during the atmospheric river in 2021, that was like one big challenge. And then this last fall was pretty hot and dry. And so there wasn't maybe enough rain to get a cover crop started coming on the heels of a pretty hot and dry summer, so maybe there wasn't a lot of water left to irrigate. So these can be really dynamic decisions and hard to plan super far ahead, super reliably. So some other constraints to consider would be, the cost of the seed itself, and then whatever your the modality of planting or termination. So do you have the equipment to mow the cover crop down if that's how you want to manage it? Are you going to tarp it to kill it? Do you have the tarps? Do you have a tiller? And then if you are going to plant with a drill and a large space, or do you want to broadcast seed? So do you have what you need and the labor to manage it? And then additionally, you can think about tillage, you can think about pest and disease cycles. So in some cases, cover crops can really work to break up pest and disease cycles, particularly when I think about kind of like vegetable or flower farms. There's not a lot of cereals grown generally, and having some sort of cereal in the ground might not be a host for all of the same pests that you would see otherwise. However, if you're growing a lot of brassicas as a vegetable or a flower farmer, you might not want to choose a brassica cover crop because you would be at risk of some of these pest and disease cycles perpetuating. You're creating a bridge from season to season for some of those pest issues. So when we talk about really common species in the this area of the world, so kind of south coastal B.C. and kind of generally, I would say, there's two main categories. So we have cereal cover crops and we have legume cover crops. And cereals are going to be kind of your rye, your wheat, your triticale, these types of grasses mostly. And then legumes are going to be things like peas, clover, vetch, and they are very different. So these species offer really different benefits and challenges. So the cereals are going to be your high biomass crops. They're going to often be, depending on which one you choose, particularly winter hardy. They have very fibrous root systems, so they're going to have a high capacity to keep soil in place and scavenge for residual nutrients. Whereas legumes are mostly used for their nitrogen contribution. So legumes have this capacity to fix nitrogen. They can pull nitrogen out of the air and turn it into a form that is available to plants, which is a really amazing feat. If you think we're just, every breath we take, breathing in 80% nitrogen and just exhaling it right back out. Only very few microorganisms have this capacity to turn that nitrogen into something that can be used by terrestrial species, and legumes are one of them, or legumes form an association with these microbes. So when we add legumes to a cover crop mix, we're kind of increasing the amount of nitrogen that might be potentially available for our future cash crops, and that might be one of our goals. So some common species in either for a winter kill or for some of these growing season or kind of alternative management desires would be forage radish. So that's also known as tillage radish, which I think that someone mentioned earlier. There's kind of large tuber radishes that have some capacity to break up compacted soil, or they're going to be a biological means of getting down into subsurface layers of the soil and breaking up some chunks, introducing air and water. Sudan grass, a really high biomass grass that it's a summer annual, I believe. It doesn't have a lot of cold tolerance, but when planted early enough can, put on a lot of biomass and then become mulch. And then barley, oats, buckwheat, and sunflower are all generally winter kill in this area, but we'll talk a little bit more about plant hardiness zones here in a minute, and how to determine kind of what will winter kill or not in your area. So I'm going to start putting some resources in the chat as we talk about them. There's a really good publication that gives, if you're one of those people that is new to cover cropping and you want a detailed layout of kind of the benefits versus the challenges and kind of why cover cropping, this is a great place to start. The University of Oregon, or sorry, Oregon State University has done a lot of cover cropping work, especially on small farms. So if you are living on the West Coast, this is like a pretty good resource. And they often work in collaboration with the USDA and Corvallis as well. So go ahead and check that out if that is of interest to you. And maybe here I'll also add that generally speaking, people are growing more than one cover crop species at a time. So it's pretty common for us to do a mix of cereals and legumes, or, if you're familiar with any of Kevin Elmy's work, who I believe he lives in Saskatchewan, but he wrote cover cropping in Western Canada and does a lot of consulting in the cover cropping world. He creates these mixes of 10, 15 species at a time. And that can be really beneficial. We can get at multiple goals with multiple cover crops. We can increase the amount of coverage we have over the soil, better weed control, but we run into management complexities when we think about maturation timing. So it becomes more difficult to manage many species at once when we think about how are we going to kill them? How do we get them established? So those are kind of the benefits and constraints on either side of the scale when we think about mixes, and that publication there does a really good job of laying that out. So as Teresa was saying, I worked on a project last year that we built kind of a database of information about cover cropping in British Columbia. So we went out and did a literature review of a bunch of academic publications, government materials, to see what research people had done about cover crops in BC, and to build kind of like a decision matrix of how people, for which goals they have, which would be good cover crops. So eventually, I believe in BC, they're hoping and working towards building a tool for growers called a selection tool out of this database. That would be an online kind of interactive forum in which you can input information about your farming conditions and goals, and then it would help you. Oh, okay. I see that says page not found. I'm going to star that, and at the end, I'll double check that link. Anyways, so while the BC kind of information is not easily available publicly, there are a couple other tools that are super useful in the interim that I would love to introduce you to if you don't know them already. So the first is the Pacific Northwest Cover Crop Selection Tool. And the power of this tool, especially for those of us in BC, is that it's the closest regionally to us. So this has information from Oregon, Washington, and Idaho. So if we're in kind of the more temperate areas of British Columbia, that data set is going to be pretty applicable to us. And to the downside of this particular cover crop selection tool is that it is pretty cumbersome to use. So you have to go to this website, you download a zip file, you need to have access to Microsoft Access and Microsoft Word to make it work. Which is just not the most user-friendly way to go about this. But there is an Excel sheet of just the raw information from this database that if you are someone who feels comfortable kind of hunting your way through a spreadsheet, might provide some good information. I'm happy to supply that to you. I have a copy. And then the second tool, which we're going to kind of take a tour of here in a minute, is the Northeast Cover Crop Council Selection Tool. So this was developed in the Northeastern United States. So it has kind of the opposite pros and cons as the Pacific Northwest selection tool, and that this one is not regionally kind of developed. This is a much different growing climate than we have in BC, although for some of you others joining from the East Coast, this might be good anyways. But it's extremely user-friendly. It's a really powerful tool. It has some good kind of modular components that I can show you. And it's organized by plant hardiness zone. So you can get a good idea of some of these survival traits, even though it's for a different area. And because this is based on plant hardiness zones, I just also wanted to direct folks to, if you don't know what plant hardiness zone you're in, this is something you can just Google. This is a map of British Columbia, so you can like more or less see where you're at. The Northeast Cover Crop Selection Tool only has plant hardiness zones of, let's see, zones 4 through 7. So they don't even have a zone 8, which is like where I am, for example. So this is going to be a milder climate than is even described by this particular tool. So it's just like something to keep in mind. All right, I'm going to, how are we doing? Can I get, how are people doing? Do you have any questions as of now? Anything you want me to say one more time or elaborate on?
Can I actually just quickly ask a question?
Please, yeah.
You mentioned that okay, I didn't quite catch what you said you could give us the spreadsheet for. Was it once you actually go in and download all of those cover crops, or what would that? I just missed part of how you described it.
Totally. Yeah, that wasn't super
Thanks.
clear. So I was talking about the Pacific Northwest Cover Crop Selection Tool, and the information they have publicly available on their website is this kind of clunky version where you download an Access file, which is like a database software, and then there's a Microsoft Word file that has kind of instructions. However, a lot of people don't have either of those tools. So I contacted these folks and just got the like raw date, like the Excel file that feeds into this tool. And they have told me that it's fine for me to give that away because it's publicly available information. It's just not on their website. So if you wanted to bypass this kind of system of downloading their things, I would be happy if you gave me your email to just send you the Excel file. It's not gonna there's no interpretation in it. So it's like you're looking at just like the raw information that they've put in there. But for some people that have some good fluency in how to, filter and sort, that might be not such a bad thing to look at. So is that clear?
Yeah, totally. Thanks so much.
Yeah, for sure. Okay, with that, I'm going to put a link in the chat for this Northeast Cover Crop Selection Tool, and then I'm going to share my screen and we'll go through some of the tools together. So you can either save this link for later and just watch my screen, or you can follow along or just start kind of exploring. So just give me 1 second here to switch my share screen. Has anyone used any of these selection tools before? Or heard of them even?
No, I have not.
Okay, yeah, it's pretty interesting. They have there's even one built in Canada. It was like Manitoba, Saskatchewan, Ontario kind of zone. But I don't believe it's operational anymore. However, in almost every region of the US, they have cover crop councils that have put together this type of information. So between, the kind of 5 that are available, you can piece together some pretty good information. But this one is my favorite, which is why I am talking about it. It is definitely the most user-friendly. It has the most pictures. It's just like a good time all around. Can you all see my screen again? Okay. So if you have made it here to this page or just kind of following along, there's the first thing is this kind of plant hardiness zone selection. So that's like the first layer of information that you put in. So I'm going to select zone 7, that's closest to where I am. And then at the top here, you can see it says cover crop explorer, and then it also says species selector tool. So we're going to look at the explorer first. And this is basically giving me everything in alphabetical order that I can grow in this plant hardiness zone. And it is a long list of things. So we have, vetch, sunflower, soybeans, Sudan grass, ryegrass. Some of these might look familiar. Here's that tillage radish that we were talking about earlier. And then for each one of these, you can hit view crop details, and it gives you a description, and then it gives you a rating 1 to 5 of how well this particular cover crop does for any given goal. And all of the goals are defined if you just hover over them. So nitrogen scavenging is defined as the ability of this cover crop to take up and store excess nitrogen that would be left over after your cash crop or growing season has come out of the field or ended. There's also information about weeds, environmental tolerance. So how well does this particular species withstand drought or standing water, really saline soils, and then some kind of general information about what type of plant this is. So the growth traits, so it'll tell you if it's a perennial or an annual, what its habit is, and then some information about in what soil conditions this will do well. So for those of you with really heavy soils, you might want to be paying extra attention to kind of things like pH or texture in your selection process. And then information about drainage and planting and termination. So quite a bit of information provided. And then the one thing to know about these databases is they're often created based on expert opinion. So what they do is get a bunch of farmers together, agrologists, extension specialists, people who have been working with cover crops and have pertinent knowledge, and they bring them into kind of like focus groups where they go through species by species, trait by trait, and they all kind of have to agree on the rating for it or the description. And anything that didn't fit neatly into these categories that are provided were noted and then given as notes at the bottom. So there's some really good information that's kind of this born of experiential knowledge about these cover crops in this kind of extended comments section. So this is a good place to scroll all the way to the bottom. It's worth it. You can print these directly if you're someone who works on paper. And the only caution I would have here is kind of this calendar. This is going to be the thing that's going to be the least reliable given we're not in this area. We're not in this hardiness zone. So just take care with the planting timing, but a lot of the other characteristics I would expect to hold pretty true. So this is the Explorer tool. You can also use the Selector tool, which is another tab just right here at the top. So if you click on this, this takes you to kind of, well, we'll just see. So the first thing that you do is you put in your physical location. So this is like built obviously for the Eastern United States. You do have the capacity to change it. Like if we go to Vancouver Island, not too far from where I am, there's some really nice farmland up this way. So if I was to just say that this is where my farm is, even though it's outside of the tool area, it's still recognizing that more like the closest thing that to me is zone 7. The next thing that you do is you put in some information about your the water movement on your farm and the soil. So you can indicate if your soils are somewhat poorly drained, well drained, etc. So we'll just say that I'm working on moderately drained soils, and then the flooding frequency. And then keep moving. It's going to give an average frost date, average precipitation, and frost-free days just based on your plant hardiness zone. You can edit these values if you know better. If you want to kind of give the tool more like a finer scale, finer resolution of data about where you're farming. So you can alter those. And then here's where you pick your goals. So again, I see this is even constrained to 3. So you can select up to 3 goals. So I'm going to take some suggestions from the crowd here. If you want to put them in the chats, what are some goals that you would be interested in looking at just for this demo? Let's maybe take 2. All right, organic matter and nitrogen fixation. Great, thank you. Okay, so we want something that will improve soil organic matter and will fix nitrogen. And now this is giving me a curated list of the cover crops based on the goals that I've selected. So let's that. So we can see here, I have goal 1, which was improve organic matter, and goal 2, and it has pulled out the rating for that cover crop for that trait. So we can see like alfalfa is a 3 out of 5 on improves organic matter, but a 5 out of 5 on nitrogen fixation. And then you can still access that full kind of suite of characteristics if you just hit more details. And then if you hit add to list, it gives you this cover crop list tab at the top. So if you had to you wanted to flag a couple, you wanted to be able to really compare, let's do like crimson clover and red clover. And maybe we have a vetch or something in here. And hairy vetch. So now when I go to my list, I have these 3 cover crops, and you can, hit comparison view. And now it's giving me a side-by-side view of these cover crops. And I can choose different traits that I'm interested in. So maybe I'm interested in the root architecture. Okay, they all have tap roots. Maybe I'm interested in, I saw in the chat that there was outcompete weeds. So I could, oh wait, this is if your cover crop will become a weed. But this persistence. So I can see there's a big difference. Red clover and hairy vetch have a much higher likelihood of becoming a weed problem setting seed than crimson clover. So that might be something I want to consider. And then you have at the bottom always this average goal rating. So this is averaging the ratings for the organic matter and the nitrogen fixation that I picked originally. So those are kind of like the 3 tools within this tool. There's the Explorer, where you can just look at anything that can be grown in your plant hardiness zone. The species selector tool, where you input information about your goals and your location. And then this comparison tool that lets you select cover crops and compare them directly. How are we doing with that? Yeah, really useful. Very useful, even in just sometimes you're like, okay, I know that I've heard that there's white clover and there's red clover and there's crimson clover. Because they're clover, I know that they all fix nitrogen, but are they all even annuals? Do they all have the same minimum germination temperature? Are they all the same height? Like, what's really the difference? And this is a great way to start getting some of that information. Okay, just in the interest of keeping track of time here, we are at 1:30 and we go till 2, correct, Teresa?
Yes, that's correct.
Sweet. Okay, I think I will switch over to my PowerPoint. Give me 1 second. I'm also going to grab some water. Stop share. All right, let's take a 2-minute break here. We've got time for it. So if you need to like get up and like jump around or go to the washroom or whatever, we'll reconvene here in another moment. Or you can check out that cover crop tool. I just have a couple of more slides and then we can move into any sort of questions or discussion that you have after taking in some of this information. I know there's a lot here, so. All right, for those of you with your cameras off, would you mind like giving a thumbs up or just put something in the chat so I know people are back before I keep moving? Okay. Right on. Looks like people are around. So there were a couple of questions that people sent in prior to the session that I wanted to provide at least some resources for. And this is a question that I think comes up a lot and is one of the more difficult questions to answer in terms of cover crop management. And so I've put this one here to start. And the question reads, how long does it take for nitrogen produced by N-fixing overwintered cover crops to be available to cultivated crops? Will I ever be able to produce enough N with cover crops to meet the needs of cash crops? Yeah, really big question there. So just to kind of like further define this, we're talking about cover crops can provide nitrogen kind of 2 ways. So the first way is when they decompose. So you've grown a cover crop, there's nitrogen in the biomass of that cover crop. As it decomposes, that nitrogen will be partially released into the soil. As it's further decomposed, it will be transformed into what we call plant available nitrogen, or PAN, that can be readily taken up by your cash crops. There's also, when we talk about nitrogen fixing crops, there's potential for nitrogen to be released kind of directly while the cover crops are growing, or those nitrogen fixing crops tend to be higher in nitrogen themselves in their own biomass that can also be released as they decompose. So there's kind of that decomposition nitrogen and then fixation nitrogen. And then, yeah, so this question is specifically asking about overwintered cover crops. So thinking about how you could scavenge or build nitrogen over the winter to be released in the next growing season. So the best resource I know to answer this question is Estimating Plant Available Nitrogen Release from Cover Crops, a really aptly named publication. And then I want to give you the PDF. I'm going to put a couple of PDFs in the chat at the end of this session. This will be one of them, but I can't find out on my screen at this exact moment. But this is a publication that came out of Oregon State University, I was talking about earlier. And in general, what they've done is done a lot of trials, a lot of field trials where they grow cover crops and then they measure the amount of nitrogen in the cover crops themselves, and then they measure the amount of nitrogen released into the soil once they're terminated over time. And then using that information, built a calculator that can kind of estimate how much nitrogen might be released from a cover crop given a variety of different factors. So the actual, like if you wanted to physically actually know what type of nitrogen is in your field, You could send in plant samples to a lab and they could tell you the nitrogen content, and you would essentially multiply the amount of nitrogen by the weight of the cover crop, by how much cover crop is in your field. But often the timing of that isn't like realistic, or the expense of that isn't realistic. So these calculators are designed to kind of model what you would expect given what species you've grown and at what time you have terminated them. So there's kind of two big factors that you have to consider: what you've grown, what species you've grown, and when you have killed it. So in general, cereals have a much lower nitrogen content in their biomass than legumes do. And then here, I'll just move to this figure so we can, might be easier to visualize this. So this is a graph where we're looking at the amounts of plants available nitrogen that gets released into the soil over time, based on when it was killed. So we have on the y-axis here the amount of nitrogen. This is Pan. And then we have the date of termination. So this is March 1st, April 1st through June 1st. And then we have 4 different options of cover crops. So this is a straight up cereal cover crop. In this case, it was rye. And then they had 2 mixes that they tried. So they tried a 25% legume, which was common vetch, and then 75% rye. Then they had a mix that was mostly legume and a little bit of rye. And then they had just straight legume or vetch. And then they also have put in here the growth stage of the plant, which is quite helpful because depending on where you are, the phenology or the stage of plant maturation might be different on a given date. So for cereals, they have the tillering stage, the joint stage, and the boot stage. And for legumes, they have the vegetative growth and budding. And it's good to note that right here is 0 on this graph. So this is 0 nitrogen added if we go across here. And when we look at that, we notice that cover crops do actually have the capacity to take or steal nitrogen from the soil. So it's not a guarantee that cover crops will add nitrogen. You have to manage them to add nitrogen through your timing and species selection. So in general, cover crops that are just a cereal can provide a net positive of nitrogen when they are terminated before, like in this kind of tillering stage before they've started noding or jointing. And we'll look at some pictures of that. Then the more legumes that you add to a mix, the more nitrogen you end up with, essentially. And that nitrogen increases over time. So if you just let those legumes grow into the spring, the amount of nitrogen that will be released from them continues to increase until they start to bud. So once it starts to move into this flowering stage, that's when either the amount of nitrogen kind of plateaus or starts to decline. So this graph is from the publication that I'll give you the link to. It's very, very well explained. It's a very accessible kind of couple of pages. So if this was your question about nitrogen, I encourage you to check this out. And just to kind of highlight this kind of tillering joint boot stage. When we talk about tillering, this is what I've highlighted here. So this is like really early on in a cereal grain's life. And when we start talking about, this is the Feek scale. So this is one way that you can define the plant stage of a cereal crop. The other stages noted on that graph were this like one node or one joint stage. So now we're talking about when the grass starts to like send up the longer stem. And then by early boot stage, that's when the seed head itself is starting to form, and you can kind of like see it's there's like an engorged part of the stem that will eventually become the seed. And often if you're someone who's already grown cover crops, you might push the cover crops, keep them in the field into kind of these later stages, because you're looking at all of that biomass being like, wow, look at all of this great carbon. And it is great carbon, but it's also important to consider that the trade-off here is that you're potentially pulling a lot of nitrogen out of the soil. So letting things mature further, generally, like if you just wanted to think about the relationship, is like more mature things are less nitrogen. Younger plants have more nitrogen. So that's kind of like the framework there. And then there's some really good thresholds in that publication in terms of like total nitrogen content in a plant, and like what's going to be positive addition to your soil and what's going to be detractant. Okay, and then I think we have time to talk about this one last question. So this is a question about waterfowl grazing, which for those of you who maybe aren't joining from B.C, this is kind of a big topic of conversation out here. We're in a waterfowl migratory path, and in the winter and fall, and for those of you who are actually farming in this zone, please correct me if I get any of these details wrong, but in the fall and the winter, there are snow geese and ducks and other migratory birds that come live in the cover crop fields, and they eat them all the way down, often completely bare. And so this is a question about, I'll read it here. Am I still benefiting from overwintered cover crops when a cover crop is eaten to the ground in November, December? Some does regrow in the spring, but how much damage are the waterfowl doing? And can I take any consolation in that their droppings are left behind? And this is a really good question, and a question of ongoing kind of research. I don't know the exact answer to this in terms of the impact of these birds to the like soil structure, the kind of cost benefit analysis of just leaving it bare anyways. But I did want to just pull out this one resource. So this is the Delta Farmland and Wildlife Trust, their kind of 20-year analysis, like report of their program about winter cover cropping in this area with all of these waterfowl. And then they did an experiment for a couple of years in 2006 and 2007 that's highlighted in this report that I can also give you the PDF to, that looked at the intensity of grazing of these birds on different types of cover crops, and then also kind of the amount of cover provided by different types of cover crop given the grazing. So we're just going to look at two figures here. Here we have our y-axis, that is grazing intensity. So this is like 100 is like a lot of grazing action happening in those fields, a lot of birds eating the cover crop. And then on the x-axis, we have the month of the year. So this is 2006 and 2007. And then the cover crops represented here are barley, winter wheat, oat, and rye. And there's kind of two main points here. The first is that for all of the cover crops, by the time March rolls around, 60 to 80% of the field has been grazed. So that's like a pretty considerable amount. But there's a slight difference kind of like in the trend here. So the winter wheat and the rye, a lot of predation happens quite quickly in like November and December, and then it kind of like tapers off. Whereas there's kind of like a more even grazing action from the birds in the barley and the oats. So that could potentially inform some sort of like selection of species given kind of like the timing that you're going for. The other thing to note though here is that the planting dates were not the same for these species. So part of this is that, there's just like a lot more biomass in the oats and the barley because they were planted early. And then the last figure we'll look at together here is from the same study, the same data set. They were looking at, okay, we know then how much grazing happened, but how much of the biomass is left in the field. So this is a live biomass index. So 0 would be very little cover crop to a lot of cover crop. And then again, we have the months of the year, and we see kind of what we would expect in the way that we start with cover crop and then the birds eat it. However, there's a difference in certainly in December and in January. And they calculated that, when it's all said and done, the barley and oats provided about 45% cover over the whole winter period, whereas the winter wheat and winter rye provided only about 25% cover. So neither are great, but, kind of a notable difference in the amount of cover provided over that whole winter season. So I'll give you this resource as well. It's a good one to read if you haven't already and you are a grower in one of those conditions. And then I never talk about cover crops without giving you the link to this publication. This is a publication by SARE in the US, and it is Managing Cover Crops Profitably. This is a great both overview of cover cropping and really good information in kind of like the nitty gritty. So if you have a cover crop in mind, this is a great place to go to and get kind of more detailed information. Okay, with that, I think I'm going to stop my share so I can see everyone again, but I'm happy to pull up a slide if you had questions about any of those figures or anything we talked about. But thank you for your attention. Staying with me, and I want to open it up to kind of questions here in the last couple of minutes.
Thanks, Raelani. At this point, I'm just going to say thank you. That was an amazing presentation. Really enjoyed it. And I think you shared a lot of great resources, and maybe you could send them to me and I can just pass them on to everyone who was here because I have emails. And at this point, I'm just going to stop the recording so that people can feel free to ask questions and not be on YouTube.